Today I will be showing you how to verify fracture analysis in Ansys using this calculation for an edge crack finite width plate in tension. This is done by calculating the stress intensity factor, which is a non-dimensional factor, times by the stress in tension times by the square root of pi times a, which is the length of the crack. First you have to work out this y, which is a non-dimensional factor, using a and w, the length of the crack and the width of the plate. You simply insert in a and w, which has to be less than 0.65, and since a is 5 and w is 25, our a over w is 0.2, so it fits in this criteria. And this works out to give you a y value of 0.3795. You then multiply this by the 100 megapascal stress, and then times by pi times by the length of the crack in the square root. And this gives you 17.289 megapascals square root meter. Now we put this into Ansys. First we go into geometry and make sure the analysis is 2D. We then create the sketch of the plate with these dimensions here, which are the same as the dimensions shown here. It's quite simple to create. You only have to make sure that this crack is the exact geometry that's meant to be, as this will have a big impact in the stress. You then simply create a surface from this sketch, then you're ready to go into Ansys Mechanical. First of all, we make sure the 2D behavior is plane strain, and then our material is structural steel. We then create a new coordinate system at the vertex right at the tip of the crack, and then we apply this mesh. As you can see, this is an unstructured mesh, as because of the crack it can only be unstructured, and this is completely different to the structured meshes I've created before, as it needs to be refined around the crack. First, just a simple face mesh of 0.05 meters, and then a vertex sizing, and again this is the tip of the crack, and then we use a sphere of influence, and it has a radius of 0.06, which encompasses the whole of the crack, and then a really small element size of 0.003 meters, and this creates a really fine mesh around the crack and a less fine mesh around the edges of the plate. Then we insert a fracture tool, which links back to this fracture tool, which works out the stress concentration factor. So first we need to mesh the crack. So first we make a name selection at this vertex, at the tip of the crack, and then we get a nodal from this name selection. So now there's this vertex here, the exact tip of the crack. This now has a node which feeds into the pre-mesh crack. So we select this crack tip node, and the coordinate system we've created. Then in static structural, we create a frictionless support here, and then a displacement at one of the corners, and this means the plate will not move in space. And then we apply a force and tension, and this is 250 newtons because it's 25 millimeters, so that gives us 100 megapascals, just like the diagram here. And then we get our solution with total deformation, and because it's been pulled apart there'll be most deformation here. Our equivalent stress, so it's low around the edges of the crack, and then pretty low around here, but there's high stress right at the tip of the crack, and then a butterfly wing of more stress around here as it gets pulled apart. And then that's quite similar to the normal stress in the y-axis, creates a very similar stress plot. And then we just go into and get our stress intensity factor from here. and this is 0.7082 times 10 to the 7 Pascals square root meter, which equals 17.082 megapascals square root meter. And this only has a 1% difference to the stress intensity factor created from the equations. So this shows that it's actually a really good approximation for what Ansys gives you. And this is how you verify your fracture analysis that you've computed from Ansys with these simple equations.